All right, functions class, this is a problem that we started with today, and I want to make sure that we are still able to do it. So go ahead and hit pause and try to do this. Okay, so I've already got my triangle set up. I wrote that out. So I am given that my angle C is 90 degrees. So I know that that's that part. And since I know that that's 90 degrees, I went ahead and decided that that was going to be my angle A. And since that's my angle A, the opposite side has to be my A length side, which is given. And then by process of elimination, that's my angle B. And since that's my angle B, then that has to be my B side length. So now I'm going to find the missing parts. Now I'm given two things. I'm given two side lengths, so I can find my hypotenuse, right? I can use the Pythagorean theorem. And since I'm using the Pythagorean theorem, I can do c squared is equal to a squared plus b squared. And then I'm just going to plug in the parts that I know. So I don't know what my hypotenuse is, so I'm going to plug in my two legs. I plug those in, I get that. I add them together. I take the square root of both sides. And I end up with C being about 71.27 centimeters. Now, here's the deal. The problem gives us things given to the second decimal place, so that's how I knew where to round. Just like in chemistry, we're going to use the same what we're given. Sorry, I'm messing with my hair. Okay, so then we know that that is 71.27 centimeters. Now I've got to find some missing angles. So I'm given, let's look at angle A. And I choose angle A just simply based on the fact that I want to go in alphabetical order. I could have started with angle B. I'm given the opposite. Now remember, we always want to use our givens. We don't want to use the information we found. What if I rounded wrong? So in second period today, I had a student who rounded wrong and then got the wrong answer altogether for everything else because he didn't use the given. So that's an instance where you want to. So I'm going to use the two information pieces that I'm given. Well, I'm given my, let's see if I can get this. I've got my opposite side and I've got my adjacent side. And if I know SOHCAHTOA, tangent has opposite and adjacent that will help me solve. So I'm going to go ahead and find the tangent. So if I do that, I'm going to plug in the pieces I know, and I know the side length. So that means I'm solving for an angle, and whenever I'm solving for an angle, that means I'm going to use the inverse of the function that I have. So if I use the inverse, then I've got to move that over. And so I know that my angle A is going to be equal to the inverse tangent of whatever that is. And when I plug that in my calculator, I get 38.38 degrees. Now, many students are like, okay, I can take down 90 minus that, I get my answer. But what if I rounded wrong? Again, I don't want to have a rounding error and get the wrong answer. So I'm going to go ahead and do tangent again. But I'm going to, whoops, that's in the wrong order. I'm going to do the tangent of B because I'm still given my opposite over my adjacent. So if I do that, I'm going to do the inverse tangent. Okay, I'm missing a piece. Oops. Okay. So then I plug that in, and since I already knew that these were just going to be switched, I did the inverse, I plugged that in, and I get 51.62 degrees. Okay, I've solved for everything that's missing. So the answer to my triangle is all put in where they belong. I got my angle A, angle B, I've got my side length C, and those were all my missings. So on Friday, we talked a little bit about angles of depression and elevation. I don't know why I'm really struggling with that word. So when we're talking about this, we're talking about the sight line, and we're talking about it as the perspective is given into the context. So if you want to put this, I know I gave us some notes on it before, but if you want to put this in your notes, you can. Go ahead and hit pause, and you can put that in there. It just kind of helps. But I want to talk about this one. So I'm going to give you a couple of minutes. I want you to set up your triangle. I'm going to set mine up, and you set yours up. And just a reminder, this is a really good example of a meeting level word problem. And the reason why it's a really good example of a meeting level word problem is I'm not giving you a picture, and you're going to have to figure it out. So we're going to talk about this, but I do want you to draw that. Okay, so I started to draw this picture. So I've got my tree, and we're saying that from the top of the tree to the point on the ground is a 60. So this is from here. And we're going to say from here, and we're just going to, we're going to go from here. Hold on. I lost my cursor. Here we go. So I'm going to draw my sight line from here to here. Pretend that's a straight line. And then I'm going to say from there, ground from here to here, and then my triangle, tall tree. Okay? So I've got 15.5 meters, but where is my sight line? Well, actually, so his sight line, this is an angle of depression, will be like this, and there's my triangle. So the triangle we're actually talking about is right there. But if this line and this line are parallel, this becomes a transversal, and this angle right here is 60.4 degrees. So then what is this angle? Well, because it's a transversal and those are parallel, this is actually 60.4 degrees. So Mr. Temple and I talked about this in class, that whether it's depression or elevation, always put the angle right here. It doesn't matter. Because of the parallel lines and the rules that we have with transversals, we know that we can always use this angle. Because if we have a little worm right here, there's a little worm that the bird is looking at, then it would be safe to say that his angle of depression to look down would be the same as his to look up to the bird, right? So we're just going to use that kind of reasoning to help us with this. But what are we actually solving for? We're solving for the height of the tree. And we don't know the height of the tree. So Mr. Temple wanted to make it very clear that when he draws a picture of this, it looks like this. There's his tree. There's the top of the tree looking down. Oops, that's the ground. Pretend all of that's straight. I'm not very good at drawing with this. This is your 60.4 degrees, 15.5 meters. He's solving for this side. Okay, it's the same as over here. You don't have to draw a picture. I'm not actually looking for a picture. So what we want to do is we're given an angle and we're given a side length. If I'm looking at this angle, I'm given the adjacent side, and what I'm looking for is the opposite side. So which one of those gives me an adjacent and opposite? Well, that's tangent. So I'm going to say that the tangent of 60.4 is going to be equal to the opposite, which I don't know what that is, over 15.5. Well, how do I get the O by itself? We'll multiply both sides by 15.5, and I get 15.5 times tangent of 60.4 is going to be equal to O. So if you plug that into your calculator, you will get, I don't remember the answer, so we're going to figure that out. So when I plug that in my calculator, I get that O is equal to 27.28 meters. So what we want to do is we want to write our answer in context. So the tree is 27.3 meters. Again, I'm given everything to the first decimal place or the 10th place, and I'm going to make it match. 27.3 meters tall. So that would be the correct answer. Make sure you give me your answers in context. All right, so that is the last thing I had for today. I did give a worksheet. I'll post that on Google Classroom if you need it. The answer key should be posted as well. If you have any questions, please ask me in class or send me an email or whatever. So I hope you have a great night, and I'll see. Oh, and the test got moved. We are not going to be taking the test tomorrow. We're going to take the test on Thursday. So if you have any questions, please let me know.